Good morning, students. Today's session I am going to discuss about how we are going to convert this finite automata to regular expression. In the previous session, we just discussed about how we are going to convert the finite automata to regular expression, right? In this case, while we are going to convert any regular expression to finite automata, we have to select the regular expression which doesn't contain any null moves. Yeah, in some cases regular expression is having null moves, we have to select any regular expression which doesn't contain any null move. And here, what do you mean by finite automata? Finite automata is collection of states and input symbols. Every finite automata is having the initial state and the one final state. Every finite automata is consisting of initial state, one initial state and number of final states, right? Now we have to use some set of rules for converting the regular expression to finite automata. We are having some set of rules how we are going to convert the regular expression to finite automata. In this class I am going to discuss about how we are going to convert the regular expression to finite automata. While we are going to convert the regular expression to finite automata, we are having three steps. First step is convert the regular expression to NFA with epsilon moves. First step is we have to convert the regular expression to NFA with epsilon moves. Next, we have to convert this NFA with epsilon moves to NFA without epsilon move. This is the second step. Then we are going to convert this NFA to DFA. NFA to DFA means that is the finite automata. Then, yeah, first step, just we have to convert this regular expression to NFA, regular expression to NFA with epsilon moves. Next step is NFA with epsilon moves to without epsilon moves. Next step is NFA without epsilon moves to DFA or finite automata. DFA or finite automata. DFA or finite automata. Here already you know that how we have to convert this NFA with epsilon moves to NFA without epsilon moves. Already we discussed in first unit only. And how we are going to convert this NFA to DFA. You know these two things, conversion of NFA with epsilon moves to NFA without epsilon moves and NFA with epsilon without epsilon moves to DFA. Now here first in this session you are going to learn about NFA conversion of regular expression to NFA with epsilon moves, right? There are some set of rules are there. By using those set of rules we are going to convert this regular expression to NFA with epsilon moves. Here, see here, if any regular expression is having epsilon move, if any regular expression is having just epsilon move, then the finite automata of that particular regular expression is just here only one state. That particular state doesn't have any input symbols A or B or 0 comma 1. That particular state, initial state is only the final state. Initial state is only the final state. If the regular expression is consisting of only one epsilon move, if the regular expression is having only epsilon move, then that particular finite automata for that regular expression is here. Initial state becomes the final state, only one state which doesn't contain any input symbols, right here. If any regular expression is consisting of null symbol, here epsilon is different and null symbol is different. If any regular expression is having null symbol, then that particular state is here only one state is there. Here this is the initial state only, this is not the final state. This is the initial state, this is not the final state, right? Q naught is there, Q naught is the initial state, that's it, right? Here in this case here Q naught is there. Here Q naught is the initial state and Q naught is the final state. Here Q naught is the initial state, Q naught is the initial state, that's it. Next, third one, if any regular expression is consisting of only one input symbol, that is A. For example, my regular expression is A. Yes, here my regular expression is A. Then here First we have to take one initial state Q1, then A, then QF, then QF final state. See here, one arc is there, here one arc is there, this is consisting of A symbol. Why? Because our regular expression is A, that is the reason here we have to take A. If my regular expression is having only one input symbol, that is A, right. Next, concatenation. If any concatenation is present in between the two symbols, here see here, regular expression is there A comma B, my regular expression is A comma B, my regular expression is A comma B, and see here my regular expression is A comma B, right. Now here we are going to convert this regular expression to NFA without epsilon moves. See here, NF finite automata without epsilon moves, finite automata without epsilon moves. Here first we have to take one state Q1, then followed by A, then next is here, see here Q2 is there, this is Q2, then followed by B, then this is QF, Q1, Q2, QF or Q3, whatever it may be. Here A, B and QF, finite automata is A, B and F, right. Now here finite automata with epsilon modes. Here in this case, here first we have to take Q naught, here A comma B, my regular expression is A comma B na, my regular expression is A comma B. So I am going to divide this A comma B into two parts here, single A, single B. Now Q naught, then M, what is M? This is M, this is M1, this is M2. I am going to dividing my regular expression into M1 and M2. So Q naught, M1 means A here, then epsilon, then here some QY means Q2, Q3, Q4, whatever it may be, then M2, what is M2 here? B, M2 is B, then QF. This is finite automata with epsilon modes. Here I am going to draw this finite automata for A comma B. My regular expression is A comma B. Now here I am going to draw the finite automata with epsilon modes. First Q naught, A, Q1, see here M1 is A, then followed by the epsilon, Q2, here this is QY now, instead of QY I am writing Q2, then M2, what is M2? That is B, then Q3, see here. This is my finite automata with epsilon modes. First M1 is there, M1 is going to represent A, then Q1, then epsilon, then Q2, then Q3. For example, my regular expression is RE is 0, 1, 0. This is my regular expression. Now I am going to, here it is consisting of three symbols 0, 1, 0. It consisting of three symbols 0, 1, 0. Now what is my regular expression for this one? First we have to start with the initial state Q naught, then here M1 is there, see here M1 is there, that's the reason we have to take 0, then followed by epsilon, right, then Q2, after epsilon again we are having one symbol, so 1, then Q3, again epsilon, again Q4, then 0, then QF, final state. Let's see here 0, here I am going to divide this complete string into three parts, M1, M2, M3. So first M1, Q naught M1, that is 0, next state, next is epsilon, then Q2, next is M2, M2 is 1, next Q3, then followed by the epsilon, then Q4, 0, final state. So this is my concatenation. How we are going to perform concatenation? By using the epsilon, NFA with epsilon modes, right. Here just I am going to convert this NFA with epsilon moves to without epsilon move. Directly we are going to write this one, Q naught 0 Q1 1 Q2, right? Q naught, sorry, again we are having 0 symbol here. This is wrong. Here I am going to draw here. My regular expression is 0 1 0, so Q naught 0 Q1 1 Q2 0 Q3. Q3 is my final state. Q3 or Q, whatever it may be, we have to give the name for that particular state, right? We have to give the name for the particular state. That's it, right? Here, see here, I will give one more example for this one. See here, if my regular expression is my 0 1 0 1, my regular expression is 0 1 0 1. This is concatenation. Into is there, that's the reason we are going to, this is the concatenation. Here concatenation with using NFA with epsilon moves. NFA with epsilon moves. This is very, very important topic. NFA with epsilon moves. Here first is Q naught, then followed by 0, right? Then Q1 followed by epsilon. See here, Q1 then followed by epsilon, then M2, right? So epsilon, then Q2, then 1 Q3, then epsilon, then Q4, right? 0 1, then is epsilon, then again 0, next Q5 0 1 0, then epsilon, Q6 1 Q7. Now Q7 becomes our final state, right? Q7 becomes our final state, right? 0 followed by the epsilon, 1 followed by the epsilon, then 0 followed by the epsilon, 1, then that is the final state. This is the NFA with epsilon moves, right? For example, for the same regular expression, now I am going to convert this NFA, same regular expression to without epsilon moves. How I am going to convert this one? Without epsilon moves. How I am going to convert this one? Here, same. Here, Q naught, right? Q naught, next 0, next Q1, next 1, next Q2, next 0, Q3, 0 1 0 1, this is QF, this is QF, right? Anything. 0 1 0 1, 0 1 0 1, right? Is it clear? Up to here, any regular expression is there, that particular regular expression is in terms of concatenation. Then first we have to divide that particular regular expression into single input. See here, I am dividing here 0, then 1 0 1. Then here every input, after every input symbol we have to write this epsilon. After every input symbol we have to write this epsilon. This is the NFA with epsilon moves and NFA without epsilon moves. How we are going to perform, how we are going to construct the finite automata for the concatenation, right. Next is union, right. How we are going to perform this union? Union means plus, union means A plus B, right. Here, see here, Q1A, Q1A, then from the Q1 only we are getting the B. So, it means that for this one same, for this one, we are going to convert this one to regular expression. How we are going to convert? My regular expression is A plus B. Plus means union. Plus means union. See here, Q naught A B Q1. This is the final state. That's it. This is the finite automata without epsilon modes. Finite automata without epsilon modes. See here, in this case, concatenation means just AB. Concatenation is just AB. Union means plus AB, A plus B, 0 plus 1, right. Directly from one state we are getting A, then from the same state we are getting B. From the same state we are getting B. Here, if we are going to take finite automata with epsilon modes, first Q naught, then epsilon, Q1, Q2, then M, Q3, Q4, some x, then epsilon. For the same thing, for the same regular expression A plus B, how I am going to write for this one A plus B? First is, see here, Q naught, right, then epsilon, Q naught, epsilon, here also epsilon is there, here also epsilon is there, right. Then here Q1, then Q2, here Q1, Q2, Q3, Q4 depends upon the user. You can write anything. Either you, instead of Q0, Q1, Q2, you can write A comma B comma C also. Here just I am going to divide this A comma B into single terms, A plus B. So this is A, this is B, single input. So my M1 is A, my M1 is A. Here my B, right. M1 is A, M2 is B. Next here Q3, next here Q4, right. Next is epsilon, yeah, Q5, this is the final state, Q5 or Q6, it depends upon the user. You can write any name, for this one, Q0, epsilon, Q1, Q2, A, B, Q3, Q4, epsilon, Q5. This is the finite automata for the union. I'll explain with one more example here. For example, here A plus, 0 plus 1, 0 plus 1. First, I am going to divide this 0, one symbol, this is one more symbol, this A1 is another symbol. So first we have to start with the Q naught, epsilon, Q1, right. Now here Q2, then 0, then here 1, next is Q3, this is Q3, here Q4, next is epsilon, 5, final state, epsilon, epsilon, and this is the final state. Instead of QF, you can write any Q5 or Q6. It depends upon the user. Here, this is the 0 plus 1, right? Here, this is the NFA with epsilon moles. Na? This is NFA with epsilon moles. NFA with epsilon moles, right? Now, I am going to construct for the same thing NFA without epsilon moles. NFA without epsilon moles. How I am going to convert this NFA without epsilon moles? Directly we can write here Q naught from A, you are getting here also from B, we are getting the same state. Q naught A comma B, Q naught A comma B, right? Here, this one, right? Up to here clear? For example, now I will give one more example. Construct an NFA for the given expression, that is 0 plus 1 plus 0. 0 plus 1 plus 0. So, we have to divide the symbol into its original, into a single symbol. For example, single input state. For example, here I am going to divide my string. I am going to divide my string into two parts. First one, this is A part, this is B. This is A, this is B. This is A and this is B. Right. Now, I am going to convert this regular expression to finite automata with epsilon moles. I am going to convert this regular expression to finite automata with epsilon moles. Here A, this is completely, this is A, this is B. Now, how I am going to take this one? First is NFA with epsilon moles. NFA with epsilon moles. See here. First Q naught, right? Epsilon Q1, Q2, right? Q1, Q2. Next is here 0 plus 1, 0 plus 1. Here, I am dividing this string into two parts now. One is 0 plus 1, next is 0. So, this is Q3, this is Q4, epsilon, QF final state, QF final state, right? Here, Q1, see here, Q naught, epsilon, Q1, 0 plus 1, 0, Q3, Q4, epsilon comma epsilon, right? Now, here 0 plus 1, again here also we are having this one, again here we are having 0 plus 1. So, we have to divide this string, we have to divide this regular expression into single term. 1 is 0, 1 is 1, again this is the concatenation, again this is the concatenation. Now, you have to perform in this one. So, Q naught epsilon, I am going to concentrate 0 plus 1, I am going to concentrate 0 plus 1, 0 plus 1 is present in between these two states, 0 plus 1 is present in between Q1 and Q3. So, we have to concentrate on this one in Q1, 0 plus 1, epsilon, here you can change the state names, Q2, Q3, 0, 1, Q4, Q5, then epsilon, Q6, right? Yeah. We are this complete regular expression is present from Q1 to Q6. It is equivalent of Q1 comma Q3. In Q1 comma Q3, we are constructing the regular, we are constructing the NFA with without epsilon moles, NFA with epsilon moles, Q1 to Q3. Here, followed by the same thing, followed by the same epsilon, right? Followed by the epsilon. here, what is here, epsilon is there, so epsilon, this is my epsilon, already here it is already present, so epsilon, here qf is there, you can write qf, final state, right. Remaining here, remaining all those things are there now, remaining here 0 is there, single input is there, so no need to cancel that one, directly we can write this one. So epsilon, already q6, up to here q6 is there now, I am going to write here q7 followed by this 0, followed by this 0, then q8, right, then epsilon, this is the NFA with epsilon moles. Now you are going to convert this NFA without epsilon moles to with epsilon with epsilon moles to without epsilon moles. You are going to convert this thing, right. Here in this case, here whenever you are going to construct any finite automata with epsilon moles or without epsilon moles, every single arc, every single edge is having only single input only. Here we are having 0 plus 1 is there. So we have to split this type of regular expression. Every single edge must consisting of only one input symbol, either 0, 1 or A comma B, right, that is it. This is the union of union. Next one is the closure. This is very, very important. For a regular expression A star, we can construct the following regular finite automata in this format. Just here, see here, my regular expression is, see here, my regular expression is RE is A star. A star means that is the closure. Closure means self loop. Generally means here, if only A star is there, that is only its initial state, that is only its final state, that is the self loop. Here in this format we are going to define this self loop. This is the NFA without epsilon moles, NFA without epsilon moles. Now here if it consisting of anything q naught epsilon, here with epsilon moles means here first we have to take one initial state, this is q naught, then followed by the epsilon, then q1, what is m here, m is A, m is A, m is A, then q2, right, then followed by this epsilon, then qf or anything my final state. Now here we have to take this one, right, this is the epsilon, here also epsilon, closure, epsilon and epsilon, closure, single loop, this is the single loop, this is the, here it consists of, whenever we are going to convert this any closure into NFA with epsilon moles, it consisting of 4 states, whereas while we are going to convert this NF regular expression to without epsilon moles, it consisting of only one state for any closure. A star is there for my A star, q naught followed by the epsilon, q1, then A, then q2, then epsilon, qf. Again here one symbol is there, again here we are having one edge, from here we are having one edge, right. See here. Now here I will give one more example. Here my regular expression is 0 star. My regular expression is 0 star. How I am going to convert this regular expression with NFA without epsilon moles, directly q naught is the initial state, q1 is the final state, 0. q naught is the initial state, q naught is the final state, 0. Next is NFA without epsilon moves. NFA without epsilon moves. NFA without epsilon moves. How I am going to convert this NFA without epsilon moves? First we have to take one state Q naught, then epsilon, then Q1, then 0, then Q2, then Q2, then epsilon, Q3, this is my final state, right? Q3 from here, again from, sorry, from here. This is my closure. This is my closure for this one, right? Q naught, epsilon, Q1, 0, Q2, 0, epsilon and Q3. Here whenever we are going to convert any finite automata to regular expression, whenever we are going to convert any finite automata to regular expression, each and every edge is consisting of only single input symbol. There will be no star mark, nothing will be there. No plus, no minus, no star mark, right? Up to here we are going to convert this regular expression to these are the some cases are there. By using these cases we are going to convert this regular expression to finite automata, right? Regular expression to finite automata. Here now these are the some fundamentals. Now while we are going to convert this regular expression to finite automata, three steps are there na. Here what are the first step? Here first step is convert the regular expression into NFA with epsilon moves. Next step is convert this NFA with epsilon moves to without epsilon moves. Convert this NFA to DFA. Convert this NFA to DFA. But here in this examples directly I am giving this one directly A plus B, conversion of NFA to conversion of NFA with epsilon moves to without epsilon moves. Here you are not going to perform while you are going to solve the problem, you are not going to execute directly, you are not going to write these statements. For your convenience, I am explaining these things, but while you are going to write, while you are going to converting the regular expression to finite automata, you have to follow the procedure. You have to follow the procedure. By using that particular procedure only, you are going to convert this finite automata, regular expression to finite automata, right? Yeah. See here, example. Here construct a finite automata. Construct a finite automata for the regular expression 0, 1 star. For the regular expression 0, 1 star. How you are going to convert this one? Right? Here. My regular expression is 0, 1 star plus 1. My regular expression is 0, 1 star plus 1. Yeah, stuff here. 0, 0, 1 star plus 1, 0, 1 star plus 1, right? Here now you have just you have to concentrate on first you have to concentrate on union. Here 0, 1 star plus 1. So I am going to concentrating on this plus. Here for this plus means union. So for this union which I am going to take this one here. For this union this is the case now epsilon epsilon q1 m1 m2 q2 epsilon and epsilon. This is the case. So first I am going to dividing this symbol into 0, 1 star and 1. So first step 1, I am going to write step 1. You have to write in this step 1. Q naught epsilon epsilon q1 q2 and 0 1 star 1 q3 q4, next is epsilon qf, right? This is the final state. This is the final state, right? Q naught epsilon epsilon. Yeah, I'm dividing this regular expression into two states, 0 1 star plus 1. 0 1 star is one symbol, again 1 is there, q3 q4 epsilon epsilon qf. This is step 1. Now step 2. In step 2, here 1 is there, is here 1, is it possible to divide this symbol? No, here 0 1 star is there, so we can divide this 0 1 star into two parts. 0 is one thing, 0 is one part and 1 star is one more part. So 0 1 star means it is concatenation. Check for the concatenation. See here, this is the concatenation, q naught m q2 epsilon q4 m q. So 0 1 star. So this is the concatenation. So q naught and this one, q naught epsilon q1 is there. Now from q1 q3 we are performing this thing now. So see here, first is m, directly we can write this m now, directly we can write m. What is here? M is 0. So here I am writing 0, then q2, you can write any state name, q2, then followed by this epsilon, right? Epsilon, then q3, then followed by m2, right? Followed by the m2. M2 is, my M2 is here 1 star, my M2 is here 1 star, 1 star, then q3 here, completed here, q4, right? Completed now, here up to here 0 1 star is completed, here up to here completed, right? Now followed by the epsilon. So followed by the epsilon, here qf final state is there. So final state is there, right? Here is there any we have to divide any this regular expression? No, directly we are going to try. Already here q4 is there. Now I am going to start from here q5, 1 q6, right, epsilon, right? See here, now this is my NFA without epsilon mode, 0 epsilon q3 1 star, right? Here now here again 1 star is there. What do you mean by 1 star? 1 star means that is the closure. 1 star means closure, right? Here for the closure, which one is there for the closure? Here step 3. Here 0 is there, we are not going to divide this one. 1 is there, we are not going to divide it. 1 star. 1 star means closure. For this closure, go for the closure. See, closure. Q naught, epsilon, Q1, M1, Q2, again this epsilon, Qf. So we have to write in this format. Now here, now I am going to performing the operation here. I am going to performing the operation here. So remaining thing is as it is. So Q naught epsilon q1 0 q2 epsilon Q3, right? Q3 is there. See this one. From here to here we are going to performing the epsilon. Na? See, first epsilon followed by this one. Epsilon Q4, epsilon, epsilon Q4, then M. What is my M here? M is 1. So, this is my 1 Q5, then after M, epsilon Q6, epsilon Q6, epsilon Q6, here epsilon Q6, then here we are having one edge here, here also we are having one edge. See here Q3, from here we are performing the operation. So, Q epsilon, yeah, this is epsilon, this is epsilon, right? Remaining thing is as it is. So, epsilon QF, final state is there, right? Here everything is same now, up to here Q6 is there. Now I am going to start with the Q7, epsilon Q7, 1 Q8, then epsilon. This is the NFA with epsilon modes. Here after completion of the, after converting this regular expression to NFA with epsilon modes, you have to write the number of states. Number of states. How many states we are getting here? Number of states. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number of states are 10. This is the NFA with epsilon modes. NFA with epsilon modes. Now we have to convert this NFA with epsilon modes to without epsilon modes. NFA with epsilon modes to without epsilon modes. See here. Yeah. See here. While we are going to convert any NFA to DFA, what is my first step? First step is convert this regular expression to NFA with epsilon modes. So, here up to here step 1, in step 1 conversion of NFA to epsilon modes is completed. Next is convert this NFA with epsilon modes to without epsilon modes. Now, we are going to convert this one. Yeah, this is my step 1. So, what is my step 1 here? Convert RE to NFA with epsilon modes. Now, my step 2. What is my step 2 here? Step 2. What is my step 2? NFA with epsilon moves to NFA without epsilon moves. Right? This is my step 2. Convert NFA with epsilon moves to NFA without epsilon moves. Here directly we can, by seeing this regular expression, we can see this one 0, 1 star plus 1. So, here this one here Q naught, right, QF final state. See 0 here, this is 0, 1 star, this is 1, right, 0, 1 star, this is 1. Again this is the concatenation, 1 star means closure, So, instead of writing here 1 star, we can write here also 0 1 star, 0 1 star, 0 from 1 again 1 star, 0 1 star, right. This is the NFA without epsilon modes, NFA without epsilon modes. Here how I am going to convert this one, see here directly here I am writing 0 and 1, instead of you can write here also in this format also, see here Q naught 0 1 star, QF is there, right. This is 1. Now if I am going to convert this one, Q naught, this is the concatenation, 0 Q1, this is epsilon 1 star, right, here, then 1, this is the concatenation. So now this becomes the final state, this becomes the final state, 0 1 whole star, right. This is the conversion of NFA with epsilon modes to without epsilon modes. Now I am going to convert this NFA without epsilon modes to DFA. What is my step 3? Here I am going to write step 3. I am going to use one more pencil here. Here I am going to write step 3. Where I should write? Step 3. What is my step 3? Here, this convert this NFA with epsilon move to without epsilon moves to DFA, right. How we are going to convert this finite automata for this one? Here for this one, here you have to write this transaction table for this one. For this thing, what is the transaction table for this one? Here Q naught is the initial state, QF is the final state. Here how many number of inputs? 0, 1, Q naught on 0, QF, Q naught on 1, QF, Q1 on 0, pi, Q1 on QF. Yeah, while we are going to convert any NFA to DFA, first we have to take the initial state, then if any we are getting if any new state, then we have to start the process, right. Yeah. 0 1, my initial state is Q naught on 0, QF, Q naught on 0, QF, Q naught on 1, QF, Q naught on 1, QF only. Here which state is a new state is QF is there, QF, only one new state is there. Is there any new state is there? No, QF is there, QF is not there. So we have to write the transaction for this one, QF on 0, pi, QF on 1, QF. Here which state we are getting? QF, we are getting QF, already QF is present, so stop the process. So this is our finite automata for the given NFA. Now I am going to draw the transition diagram for this one. Right, transition diagram for this NFA, for DFA. What is this one? First is the Q naught. Q naught is the initial state, QF is the final state, Q naught is the initial state, QF is the final state, Q naught on 0 is QF, Q naught on 0 is QF, Q naught on 1 is QF, Q naught on 1 is QF. Next QF on 0 is null, QF on 1 is QF only. This is the my finite automata for the regular expression 0 1 star plus 1. This is the regular expression for this one 0, 1, 0 1 star QF 1. Right. Here with this I am going to conclude this one. You have to solve the next problem here. This is your homework problem. Yeah, this one. Right. Zero, 1, 0, here 1, 0, 1, see here 1, 0 plus 1 whole star 0. You have to solve this one, right. with this I am going to conclude this one. Thank you.